Okay, everybody, welcome to our webinar. You asked, we answered. Today is our webinar in English. So with the gong from we start our webinar. And if everybody can hear us, please give us a thumb up so we see and we know that everybody is here, everybody can us hear, and everybody can see us. And yes, I will say let's jump directly into the theme.
Yeah. I want to welcome you also. So I'm happy to have you here, everybody. And our main topic today will be genetic diversity testing in dogs. And before the spot is on you and you can ask your questions, I've prepared just a few slides to bring everybody on the, let's say, same level and to give you a rough overview what genetic tests or genetic diversity is and what can be covered and what can be solutions or possibility to manage populations for breeders and breeding clubs. And I would say we jump directly into the presentation. And so we will share it. You should see it now on the screen. And let's jump into it, I would say. So, I mean, when we are breeding dogs, we are in different breeds, we are dealing with genetic disorders. And we have two different kinds of genetic disorders making troubles actually. So that's so-called absolute genetic defects. So that means a dog is being at risk for a special genetic disorder. And independently from other factors, the dog will develop this disorder, even if he reaches a special age. And so this is very clear in most cases, or in a lot of cases we can test these risks and we can say very clear, will the dog suffer from a genetic disorder or not? And it's a bit different to genetic predispositions because here we have the problem that we do not only have something in the DNA of a dog that makes troubles. To develop a disorder, we have additional factors like external factors, and both together can lead to developing symptoms. But even if a dog has a genetic risk in its DNA, it doesn't mean the dog must develop the disorders in any case. And I would say these genetic predispositions are the most difficult to handle for a breeder. And for that reason, I think we have to think in a different way. So how can we avoid developing such disorders? And one possibility could be to maintain genetic diversity. Why? We have different positive effects of a high genetic diversity in dogs or in a breed or in population, let's say. And number one is reducing inbreeding depression. So we have different problems that came up with a high level of inbreeding. And the second point is to decrease genetic defects. Why? If we have a broad gene pool, this broad gene pool is able to dilute harmful recessive genes. So they do not come together from both parents, and so it reduces the risk for genetic disorders. If we have a high genetic diversity, we also have a better immune response because the immune system is able to defend a lot of different types of invaders. And the last point is adaptability. It's a nice word. If we have high genetic diversity, this enables populations to react or adapt better to environmental changes. And so there are a lot of points that go into the direction maintaining of genetic diversity, and it absolutely makes sense. So what are the problems that came up due to a loss of diversity? In most cases, we have genetic disorders. This can be indeed these complex disorders or predispositions where different factors are needed to develop symptoms. We also have let's say these easy disorders that can be tested, and we have also the reduced adaptability. And for that reason, it makes definitively sense to preserve genetic diversity and include it also in breeding as well as disorder or trait testing. So when we are talking about genetic diversity, so how can we define genetic diversity? And actually we use two different types or two different possibilities. So we have on the one hand side so-called DLA genes. That's very important genes of the immune system. That's single genes. So that means, in summary, that's three different genes that we test. And as you see in the picture, it is indeed a very, very small part of the dog we are looking at. And but it's important. It is an important part because the higher the diversity in these genes, the better is the immune system working. And on the second part, we have the total DNA. So we don't want to have a special look only on specialized genes. We also want to see what happens in the rest of the dog. And for that reason, we use thousands of different genetic markers that are included in this determination of genetic diversity. So let's give you just a crude overview of DLA genes. Maybe one of you have already heard what it is. It's the so-called dog leukocyte antigens. That's special genes of the immune system. They are essential for the immune system. So in the case that the dog wouldn't have these genes, he or she wouldn't be able to live. And the other side is these genes have a relationship with autoimmune disorders. So that means if you have a special combination of these genes, there are a lot of different types or variations is a better word, variations of this gene. And if you have special combinations, this can be correlated with autoimmune diseases. So there are different publications, and there's a lot of scientific work that can tell you which disorders are connected to special autoimmune diseases in special breeds. So why are these DLA genes are important? As I already mentioned, they are an essential component of the immune system. They have a relationship to autoimmune diseases. So in the case you detect such, let's say, risk variants, it makes sense to avoid breeding dogs in a way that this risk variants come from both parentage or from mother and father. We know that heterozygosity in these genes means higher resistance against infections, and also a lot of different studies in wild animal populations show that a minimum number of such so-called haplotypes, that's the combinations of the genes, are necessary for long-term survival of a population. Of course, it's clear, because if you have a high diversity, you have the possibility to act against different bacteria, viruses, whatever. And in the other way around, the limited number increases the risk of breed extinction due to new diseases. So when we are going to genetic diversity at the total DNA level, so we are not talking about single genes. We are talking about thousands of genetic markers, and the goal or the aim is to determine heterozygosity levels or genetic diversity based on these markers. So we have a lot of markers all over the DNA of a dog, and we use these markers for telling you what is the heterozygosity level or what is the genomic coefficient of inbreeding of a dog. So you know exactly where are you located with your breeding or with your bloodline or with your dogs compared to others of the same breed. And we are also able to find dogs with low relationships. So this is an important thing for breeding itself, to find the right mating partner. And I will show you a slide who will tell you in more detail what does it mean. So these data are indeed part of a kind of modern breeding management, because what do? We collect genetic data of dogs and of breeds, so we get a very good overview of a breed, of its genetic characteristics. We can use this for breeding management, for predictive breeding management. We can optimize the usage of genetic resources of a breed for long-time conservation. And of course we get a lot of useful information about individual dogs and of course of whole breeds. So to put everything together and to make it as easy as possible for the user and let's say understandable, we developed a platform. It is called MyFeragen platform, where we are able to include genetic information. So this can be information about disorders and traits, because we also offer a kind of screening analysis where we analyze a lot of different genetic disorders and traits. So they will be also collected in the database, but we also display diversity data like heterozygosity or inbreeding, and this is also used for the matching tool to find the right breeding partner. So when we are talking about heterozygosity, there are different things that need to be considered. And one very important thing is, for example, the number of genetic markers that are included in this heterozygosity testing. So just to give you an idea what we do when we are talking about heterozygosity, so we compare the DNA results from the mother and from the father of a dog, and we analyze how many different markers a dog inherits from the parents, and this will be displayed as a percent value. And what you can see here in this picture is, for example, the heterozygosity of a dog. So this dog has a special value of 33%. The average value of the breed is 32%, so this dog matches very well the average. And you will also see this in a kind of graph, where the blue line indicates where your dog is located. The blue curve in this case shows you the heterozygosity values of all dogs included in the database. And here in red, so there are a smaller number of dogs for this breed, the heterozygosity values of the special breed is shown additionally. And this is just a second example. We have something comparable also for the coefficient of inbreeding. So this will be also calculated for every dog compared to all dogs in the database, but also compared to all dogs of the same breed. And as you see, we have here a dog with a coefficient of inbreeding of 7%. The average is about 10%. We calculate the value, this COI value, for 6 generations, and and you get it listed for every dog of a breed, and you can see clearly is it in the range of how high or low inbreeding. And at the end, I would like to show you also our matching tool. So the idea behind this tool is to find out which dogs uh, are best in based on genetic information, or suit best in because we compare both DNA from a potential mother and a father and compare it, and we can tell you, is it a good match or is it not that good, because they show a high relationship in their DNA. And you can, for example, choose a dog in your account and say, show me potential partners of the same breed and match against the database. And then you get the hit list, which dogs have the highest matching score, and the higher the matching score, the better. And this means a very high matching score means a low relationship of both dogs that are compared. And this will lead to a stable or a lower COI value in the offspring of this mating. So that's a crude overview of the things that we offer actually, where we can include or what data we can include in our database. And
Okay, then I think it could be a nice thing when we make a little bit summarizing from what we hear now, because there are a lot of informations. So I think the first information was one of the first steps when you willing to analyze genetic diversity is the DLA haplotyping. So these are the basic or the entry of genetic diversity, because the markers from the autoimmune system are necessary.
yeah, exactly.
Then we have the next step. The next step are the genetic diversity markers. You showed us these slides. So the heterozygosity, it show how comparable my dog is with the others, and how many differences are in the DNA from my dog against other dogs.
Yeah. Heterozygosity tells you something about genetic diversity, let's say it like that. So which genetic markers are different from mother and father that your dog
Okay, so this means these are the result of my offspring from mother and father, and what of the DNAs get from both. I think on this stage it's very necessary to say this is not comparable with the ISAC 2020, because some of the competitors or some other companies say genetic diversity is calculating or is analyzing about ISAC 2020. And I think maybe you can say one or two sentences about this thing, because it's not possible to get an idea. We use here 60,000 markers for showing the heterozygosity. So this coverage, not all of the DNAs or not all of the DNA, but a bit more than 240 about the ISAC 2020.
Yeah, exactly. So there are some labs that use this ISAC 2020 markers for heterozygosity or genetic. They call it genetic diversity. But to be honest, to get a clear answer about genetic diversity, it needs a bit more than 230 or 40 markers. Because this is really a small part of the DNA.
And I think on the other hand, it's also necessary to understand that the ISAC committee choose this 240 markers because it's the how can I say, the possibility that these markers in each individuum are different is very high. So it makes sense from the perspective you will find a father for an offspring to choose markers that in every male are each different.
Yeah, exactly. So the markers are not they are not suitable for heterozygosity or other things in the means of genetic diversity.
Then we have, maybe I then we have the genetic EK, so the
coefficient of inbreeding.
Yes. So this means there are other competitors who showed this veil, but I think here is also understandable that the as we have here a dog like he has 7% or 30%. So not only this veil is very necessary, because this only shows how the inbreeding is in your dog. I think it's necessary from a perspective than a breeder. It's necessary when you compare both the male and the female, because I think everyone is clear that if you have an offspring with a low inbreeding coefficient, it makes no sense to say, okay, come on, we made them with the father because both have a low inbreeding. This is absolutely stupid. But if you only show on the IK wert, on the IK veil, it makes, I think it should that this is a bad thing. So it's necessary to compare both. Maybe you can also say a little bit to this.
Yeah, as Michael already said, a COI value is a very special thing for a dog. So this is for a single individual. And it tells you where it is located. Is it in the range of high or low inbreeding? But if you make a mating, it is important to compare the DNA of the potential mother and father to see if there is a high level of the same genetic markers, and or if there is a high level of relationship. And in this case, it can be a problem in the offspring, because they get a higher coefficient of inbreeding. So that means if you have two dogs having a low inbreeding coefficient, it doesn't mean it is automatically a perfect match, because you also have to look how different or how similar is the DNA of the potential mother and father.
So
and the other way around, you can have two dogs with a high level of inbreeding and it can be a perfect match. So this is, I think, the most important thing, to go the next step, to really compare the DNA of both dogs and to see or get an idea how is the relationship of those.
So it's a bad idea to say to know the coefficient of inbreeding is the goal.
Yeah.
No, this is 2 miles before you are in the goal. So it's you must make the next step and compare this, as Anja say. Okay. I think then we can jump into, let's jump into the questions and answers.
Yeah.
So maybe if you have questions now, it's the right time to use the chat function. So in the meantime, while we are waiting of the first questions, maybe you can say a little bit about what's upcoming in the Feragen dog check, or the new evaluation of the dog check.
Yeah. So maybe important information for the breeders. We actually have an update in our genetic screening. So that means there will come additional disorders, and I think we also have a few traits, but mainly disorders that will be included. So I've already seen the data, they look great, and I think there will be, in the next few days, there will be the release. And for all those people who already or whether dogs have already been tested on the new version of our screening analysis, they will be updated automatically. So this is, I think we started in August, at the beginning of August, and all dogs that have been tested from that point of time on, they will get an automatic update. And we actually have a lot of different disorders and traits in the pipeline. And so if something is released, all the dogs that have been already tested will get this update for free. And we are also working on making this matching tool a bit more, let's say, what is it in English? Refine is sharpening.
Sharpening the findings.
Yeah, exactly. So we try to include also the informations about the disorders, or for example, there can be also problematic traits like coat colors like merle or for example harlequin. And we will also include these informations in the matchings so that you can see at a glance that, for example, two potential breeding partners that maybe have a very good match or would be a very good match, that both, for example, are carrier of the same disorder. And yeah, this is so there are different things that will come up in the next few months. Also, we are trying to include a kind of, yeah, let's say statistics or analysis for breeding clubs to tell them about the number of carriers or haplotypes or whatever is of interest. And this is what we are actually working on.
Okay. It looks like nobody has a question.
Wow, very clear.
I think everything is clear. Maybe I think we have a few minutes left, so maybe we can talk a little bit or other. What are most of the questions that every time upcoming about genetic diversity?
Yeah, what are the classic questions? Let me think about it. What we see, for example, is when we calculate coefficients of inbreeding. So it can be, you must imagine that these coefficients of inbreeding are every time recalculated when new dogs of a breed come in. Yeah. And that means every dog is reanalyzed, and in some cases it can be that a dog has on the one time 7% of a COI value, and for example when new dogs are included, the same dog has a value of 6%. So this can be, and this is also a case of, or a matter of sharpening data, because you must imagine that with every dog comes in or comes additionally to a breed, we get more information about the genetic makeup of this dog, and that means we are learning with every dog. And it can happen that, for example, a dog who has a COI value of 7 changes to 6, for example. What we do not expect or ever seen is to have a value of 7 and then it is only 2%. So this would be a really high change we have never seen so far, but small changes in the region of 1% up or down, this can be.
So there's one question. Animal diversity was invented in 1995. Where were you two when it was invented? I think we are very young in this time.
Yeah.
I think we are too young.
Yeah.
But I think from my mind, there is also one question every time is upcoming. So this means normally how many ancestors do you go in the deepest when you analyze the data? So normally they come always how many? So we analyze about I think 6 ancestors.
Yeah, we consider 6 generations.
So this is always upcoming. Why only 6? Because we say, and then is always upcoming. Some competitors make as much as possible. So yes, but we see in Europe we start here. Or we are here in a really first step in the genetic diversity. And we are not at the same level as the Scandinavian countries or the US countries. So we decide to make the ancestors against 6 because we have in this field normally comparable to the pedigrees, because most of the breeders are using at this time the genetic diversity calculated on the papers and the pedigrees. And if you have more than 6, this is, I think,
I mean, to be honest, in former times we have calculated genetic diversity down to 50 generations, but it doesn't make a lot of sense because I would say most of the breeders or there will be no breeder who is doing population genetic science, and so it is sufficient to include 6 generations to see inbreeding within a special time, and which is absolutely okay for breeding decisions. So
and I think it's very necessary to say it makes no sense to make a discussion about 50, 30,
yeah,
20 ancestors. I think the first step must be we analyze and we do
yeah,
the tests and use the genetic diversity in the breeding daily routine, because if we don't test and analyze it, it have no
positive effects
positive
for the
effects,
dogs.
and it makes no sense to discuss about how much. I think it's necessary to start.
Yeah, exactly. So, I mean, every dog that has been calculated for 6 generations could be also calculated for 50. This is not the thing.
I think this covers also the question what's the best thing about animal diversity, but maybe you can say here 1 or 2 sentences about animal diversity.
I do not fully get the question. So, what is the best thing in genetic diversity?
I think the best thing, as we say, is to make the analysis, to make the mating,
Yeah,
and to compare the two,
yeah,
as the male and the female, to get the most information
yeah.
about the offspring.
Yeah, and I think genetic diversity is of course important because, as I already mentioned, we are dealing with a lot of different kinds of disorders which are not testable at the moment. So we have to get to be more creative, to find other ways to maintain genetic diversity, keep diversity high, to avoid bad combination of dangerous, let's say, dangerous genes.
Okay. I think so far we don't want to waste your time as much as is necessary. So I think everyone had the chance to get the answers. I hope we can help a little bit to bring informations about genetic diversity. And if you have further questions, maybe tomorrow or in the next few days, feel free to contact us.
Yeah.
There's one last question. What year was it when you first go into animal diversity? How got you into it, and why do you love it so much?
Wow, I think we started with our pilot project. It's been Rhodesian Ridgebacks, I know very well, in 2016, in 2016. And it was very complex at that point of time because we had Excel files where we had to deal with, and where we had all these values included, and it was, I mean, yeah, it was really hard at the very beginning. And then we got more and more breeding clubs who have been interested in this issue. And yeah, meanwhile, we have really a lot of different clubs that test the dogs. And sorry, why I love it so much is when you are dealing with disorders, so you always have this: the dog is a carrier, and or the dog is affected or at risk, and this is a very hard fact. So you have a very small part where you can do changes, of course, in your breeding decisions, yes, but I mean, genetic diversity is something I would say you can I don't know, influence populations. You can to have the possibility to make things better, and to improve breeds.
I think the main driven for us was to make really the puppies give the puppies more chance to get healthier and get better, because normally as we got our first dog, normally you see there are some illness or some disease, and normally you hear everything when you talk with the breeder. It's very difficult, the breeding, and it's there are a lot of disorders and a lot of things you must think when you breed dogs, and we think it could, or there could be a chance to make it a little bit easier for dog breeders and also for the new puppy parents and owners, because if you have if the breeder has the chance to make it easy to compare dogs, to breed and to make healthy things for breeding, then you have also healthy puppies, and I think at the end this is what all we want, to get healthy
and
puppies.
Of course, I mean, I'm a scientist, and I like the technology in the background, and I like the bioinformatics. So it is so funny, and so you have so much possibilities, and you can use the data in different ways, and that makes it really, lovely.
So the last question, how about doing a Q&A where animals ask your questions and a real human talking voice and you answered it for them? Yeah, I think we tried. Or got it?
How about doing a Q&A where animals ask you questions? Yeah, that would be a good idea.
That could be funny.
Yeah.
Okay, so far, we hope everybody enjoy this. I think this was our first Q&R in English, so we try to get a little bit more international. So we do our best. So if you are also, so we try also to get more and more English content, because I think, yes, we know there are some breeders, they don't German speaking. So yeah, stay tuned. Follow us on YouTube, on Facebook, Instagram, so you get every time the information that the next things is upcoming. And yeah, have a nice time and goodbye, and maybe we see you in the next time.
Goodbye also from my side. Bye-bye.
Bye.